Welcome everyone to another one of our postings for the local bridge agency innovation and demonstration days. I'd like to introduce Brian Keierleber, the Buchanan County, Iowa engineer. He's going to be talking about in this link his wood bridges. Typically, again, when we do this event on site, we do a tour of all Brian's bridges, including concrete, steel, rail car, and wood. And Brian's going to again talk about his wood bridges. Brian, go ahead.
Well, hello everybody, and we're going to start out here with the Fontana Park Bridge. Now, this was a kind of a demonstration project back about 1996. And what we have here is a 132-foot long 3-pin timber arch. So it's a wooden arch bridge. Now, if you'll notice in this view, you'll see where the pin's at the very top there. And then where the arches come into place, they are actually pinned there too. So there's no moment on this. It's all in theory in compression and on that wood. You'll see down there where the pin's at. Also, the floor beams are what the arches hold up the floor beams, and the deck's cantilevered out on the floor beams. That's all glue laminated. And you can see the ties on that and the hangers. It's a significant amount of glue laminated wood, and it was pressure treated, then laminated. County Conservation gets concerned it turns a little gray, so we kind of partner with County Conservation, and they like to put on a wood sealer on that, even though we're told that these wood structures, there's a story that there's a 3,000-year-old wooden bridge in China. Well, I haven't been over there and seen it yet, but the wood will last a long, long time if you can keep the moisture away. This is not a real good environment for keeping the moisture away because I'm just downstream from a dam, so the humidity is real high here all the time. You can see the floor beams, the hangers, the wood posts on the deck, and you can see the approaches on this. Now, it's also got an asphalt deck on this wooden bridge, and the reason for that is this is a very popular attraction with the Amish community, and the Amish community starts about a half mile away. And they run a carbide-tipped horseshoe that'll grind up asphalt, it'll grind up concrete, so we also know it'll grind up wood. So we try to be prepared and put some sacrificial asphalt on there to preserve the wood. As we go, we can see that the bridge here again is 23 years old. And there's no real deterioration on it, though we have learned in things on some later wooden bridges to put some plastic caps over the ends of those posts, and then posts will last a lot longer that way. I've not seen any deterioration here yet. We've got two different types of preservatives was used on this, and two different types of woods. They had CCA and pentachlorophenol were used on the preservatives of different members of this bridge. The arches themselves are southern yellow pine from Magnolia, Arkansas, and the deck and the balance of the materials are Douglas fir from Tualatin, Oregon. And so this was kind of a joint project from the different types of materials coming in. And again, the speed limit's reduced in here, so in this environment and everything, we didn't have to have any terminal end sections on our railing coming in. As we commented about the asphalt being taken a beating from the carbide-tipped horseshoes, it does, but it's still in pretty good shape considering all that. You'll see how the arches are tied together to give them some support, lateral support that way. It is over 14.2 tall, so we don't have to worry about posting it for height. And it's in a very unique environment where you've got camping on that corner, you've got a nature center on that corner, you've got playgrounds and equipment back on one corner, on that corner there, and the warden's house is sitting on another corner. It's right below a low-head dam. And it's an old mill, is what the old dam was in there for. And it's 132 long. At the time it was constructed, it was the longest 3-pin in existence, but now since then there's been longer ones constructed. The technology and everything keeps adding to the economics. You can see the water coming over the dam, and a lot of times it'll kind of even create a little mist coming up there, so you know the moisture's, wood's being exposed to moisture, but it's still a good location for this particular bridge because it gets a tremendous amount of pedestrian traffic and people around it. Economics on the wood varies from time to time, but the lamination is kind of what's going on. This happens to be a 70-foot long glulam beam bridge, and this is the partnership with Dwayne Bowles at Gruenwald out of South Dakota, where we worked with them on the materials. And then again, the bridge here was built with the county employees. Now the substructure, that is colored and textured concrete, and so that's a form pattern that we put in when we poured the concrete. And we built that from the beginning for the pedestrian path going out there too. And the name of this is the Cedar Rock Bridge. Now the Cedar Rock is a Frank Lloyd Wright signature house, which is about a half a mile or quarter mile from here. And it's one of the we tried to pattern the bridge with a lot of the concepts that Frank Lloyd Wright had in there, with a lot of straight lines and simple designs that way. So you'll see as we get underneath here, substructure on this was a little different because we generally have to drive 40 foot of piling. In this case, we were down there about 9 foot. Actually, the shallowest was about 12 feet to bedrock. So we've got H-piling underneath these. Again, the glulam beams, they're spaced at about 4 foot spacing, so it's a relatively tight spacing on that. It's got a wooden deck on it also. If you notice on our abutments, you'll see the beam steps, so we have an arch or crown in the deck. What happened to us too is we were doing this construction in late summer, fall, and again, this was all built with the county employees. And it turned cold on us fast, and the asphalt plant shut down. So when it came time to seal the deck off, I didn't want to, there's no way I would dare leave a wooden deck out there with that traffic on a paved road through the winter without something on it. So we used an epoxy friction course. This was something that I learned from Federal Highway, Frank Julian. I'd seen one of his presentations on how I could dramatically reduce crashes by using that. So I adapted that technology to seal off my deck. Well, sure enough, it soaked up the sealer, and you can see some marks where some of the epoxy came all the way through. But what it really did is it sealed that bridge off to where for the first few years there was absolutely no moisture coming through. Now I'm told we get some that comes through now. I haven't seen it myself. But again, if the wood's sealed off from the water, it'll virtually last forever. So if we could keep things sealed off that way, that would be a very, very good product. Again, this was a partnership with Gruenwald out of South Dakota, and they produced all this decking. We also tried to incorporate some other things, such as laminating it with adhesives. Now, we did put some heavy screws in there too, but it's an innovative bridge that way, and we use some of these concepts in future bridges after that.